Hello, welcome to this lesson where we're going to look at pi and the circumference of circles. So pi, which is written like this, is what we call an irrational number. So rational numbers, the opposite of what pi is, are numbers which can be written as a fraction of one number over another, where the bottom obviously can't be 0 because it's the bottom number of a fraction. And you can't divide by 0. So 4 over 9 would be a fraction. 4 over 9 would be a rational number. 3 is also a rational number because you could write it as 3 over 1. Any number which we can then rewrite as a fraction is a rational number. However, irrational numbers are simply any number that's not rational. So it can't be written as x over y, where y is not 0. So pi is an example of this. Pi can't be written as a fraction. And you may have seen it done like this, but it's just an approximation. There's also other numbers, such as the square root of 2 and the square root of 3, and a whole range of others. But these are just some examples of what irrational numbers are. So now we're going to look at approximations of pi. Because pi is irrational, it can't be written as a set number to any number of decimal points. It keeps going on and on and on and on. So this is what pi is to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is pi to 11 places. A lot of people might remember 3.14 as pi. It keeps going on, and there's no pattern in it whatsoever. The most easy approximation is 3, because we round it to the nearest number and we get to 3. And we're not losing all that much. This is something which you can remember for when you're trying to check your answers in your head or just estimate what an answer might be. So this is an important one to remember. But we're going to look at some others as well. This one, pi equals 22 over 7, is one which you would have seen probably a few times. And even though we see it a lot, it's actually not correct. Because if we put this out, we get to just the third decimal place. It doesn't match up. So even though it's a close approximation, it's not really correct. A much better one would be 333 over 106. But even there, we go along, we get to this decimal place, and we have a different number. Again, 355 over 113 is even better. We can keep going, but then we get to this decimal place, and we're not close enough. And you can keep going, and you will never be able to find a fraction which equals pi. So, out of this, it's important that you remember that 3 is a good approximation of pi to use when you're just checking your answers. 22 over 7 is also an okay one to use, but it's a lot harder than just 3. And also remember that pi can't be written as a fraction, anything like that. So, what is pi? We've talked about the numbers that make up pi, but how did pi come about? Pi is just a simple ratio of the circumference of any circle to its diameter. And this will be the same ratio no matter what circle you have. So, to show you how this works, I've drawn a circle down the bottom, and we take the diameter and move it to this point. So let's say that our circle is drawing, and this is our starting point, and we're going to keep going, roll our circle along until the starting point touches the bottom again. So here we have a diameter, so this is one diameter. So we go along and we have all of these are diameters. Now we roll our circle and we get to here. And the distance from the very beginning to where our red dot finishes is 3.1459, etc., etc. So this distance is what's known as pi. I'll let you rewatch it. So if we take the diameter and we put it down there 4 times, and we roll over it, we're going to get 3.1459 0.14, or pi times of the diameter, equals the circumference. So pi d equals c, and we've gotten this here by just dividing both sides by d, or the diameter. Circumference over diameter. Now this is a very useful formula when you're trying to work out what the circumference of a circle is. So as you can see, if we rearrange the definition of what pi is, we get the equation of the circumference of any circle. The circumference of any circle is pi times its diameter, because we can measure the diameter very easily, but the circumference is much harder to measure. We could then, if we didn't have the diameter of our circle, we could also go circumference equals pi 2 times pi radius, because the radius is always half the length of the diameter. So we're going to find what the circumference of this circle is, and we're given the diameter. So d equals 10. And we're going to use pi, circumference equals pi d. So c equals pi d. So we get 10 pi. So we could write this answer, c equals 10 pi centimeters, and that would be correct. We could also make an estimate and see about what it would be. We could use our estimate of pi being 3, so we get 30 centimeters. That's a bit more useful for us than, say, this one. We can actually picture what 30 centimeters looks like. Or you could find what the real one is, say, to 2 decimal places using your calculator, and we're going to get 31.42 to 2 decimal places. So while this answer is the closest, is closer than, say, this one, it's still not fully correct because we have 2 decimal places. So if you're asked to give the exact answer, you would give this one because it has pi in it. If you were given to 2 decimal places, you would give this one. All right, now we're going to find the circumference, but we're given this time the radius. So we're going to use this this formula here. So the circumference is 2 pi r. So we have 2 pi times 4, so we end up with 8 pi millimeters. So we could leave that in exact form of 8 pi millimeters. We could find approximately it's going to be 8 times 3. So 24 millimeters. Or we could find to 2 decimal places, and we're going to get 25.13 to 2 decimal places. We could also use this equation to find the radius or diameter of a circle if we know its circumference. So here we have the circumference is 10 meters, and we're asked to find what the radius is. The radius here. So we're going to take this part of the equation. So we get circumference equals 2 pi r. We know that is 10 is 2 pi r. Now we can rearrange the equation. So we get 10 divided by 2 pi equals r. So we could leave it like this is exact form, although we could simplify it. Simplify it to 5 divided by pi. So this would be the exact form of the radius. And we need to keep our measurement there. We could go approximate and use our estimate of 3 on the bottom. So 5 over 3, it's only approximately equal to 5 over 3 meters. Or you could go to 2 decimal places and you would get 1.59 meters. So now it's your turn. Can you find the circumference of this circle to 2 decimal places? So we've been given the diameter is 12. So we're going to use the equation circumference equals pi d. So we're going to get c equals 12 times pi, which then we plug into our calculator, and we're going to get 37.70 to 2 decimal places. Now we could check this using c equals 12 times pi, where pi is about 3. Sorry, that's a bit messy. And then we're going to get 36, which is pretty close to this one, so we can assume it's probably correct. Okay, this time, can you find the circumference to 2 decimal places? So we've been given the radius, so I'm going to use this. Circumference equals 2 pi r. So equals 2 pi times 3. So it equals 6 pi. The 2 decimal places, we stick it in our calculator, and we will get 9.42 centimeters to 2 decimal places. Again, we can check this using c equals 6 times 3, which will give us 18. Ooh. Yeah. So this time, can you find the diameter of this circle to 2 decimal places when we know that the circumference is 12 meters? Okay, so we use our equation, c equals pi. This time we're looking for d. So we put in what we know, 12 equals pi d. So diameter is pi over 12, which if we put that in our calculator, we're going to get 3.82 meters to 2 decimal places. And we'll check that. You can do this in your head generally. So our diameter is approximately the same as 3 over 12, which is 4. And that's pretty close to our final answer. So this is a summary of the things that we've covered here and will continue to cover in class. I hope this lesson's made sense. If you have any questions, please bring them in.